If you don't hear me, let me know. Right. Thank you. Yes, my name is Vlad. So if you haven't met me before, I'm Vlad Chernov, and I am the lead tutor for COMPOS. Lead tutor. So what do? I select the tutors that will be teaching you. I do webinars, and I also write the assignments, as you probably have seen my name on the assignment. So just a very brief overview. The physics tends to be more difficult than maths, that is true. Now, we are mostly a physics program. We are based in the Department of Physics at Oxford. And COMPOS is designed to train you to do physics and maths at a high level. Just like a sports, so like an athletics school would teach you how to, I don't know, run, be an athlete. We are the place where you come to study physics and maths at a high level. There are three ways you can do COMPOS. Well, three COMPOS programs ish running simultaneously. So there's the main COMPOS, and this is for state school students, UK state schools. There is the COMPOS Foundation. This is for private schools, and overseas student. So the difference between the two programs is that this program is free, and this is you need to pay a reasonably small fee to get in. Why is that? Because we don't receive money for we only receive money for UK state schools, and we want to make COMPOS free to everyone, but unfortunately we can't. So the fees only cover the tuition, so the actual costs of running the program. So we don't make any money. So this, and there's the follow along COMPOS. Follow along COMPOS. The difference between, so these two programs are the same. The first and the second program are the same. You get homework, yes, assignments, homework. You get tutorials in small groups, and you have webinars. That is me, right? Homework is mandatory. Now, for the follow along COMPOS, this is for everyone. Of course, you have to be the appropriate age. If you're 27, we won't accept you. Follow along COMPOS is for everyone. It is free, and it has webinars and homework, which is not mandatory. But if you do all the homework, we will treat you exactly the same as a COMPOS main student. You will receive recognition that you have completed the program, and you will be invited next year to participate in the main program or the foundation. So that's the difference between the three programs that we run. Well, so they're not really different. It's just different requirements from you. Okay. So homework mandatory. When I say homework is mandatory, it's 4 to 5 hours. 4 to 5 hours of homework per week. So COMPOS is a big commitment. You've seen homework 1. There will be 6 of those. Yes, so 6 of the homeworks, that is assignments. So 6 assignments. So 6 physics, 6 maths assignments. And we do expect you to work a lot. But this pays off. I promise that hard work pays off because 50% of students who completed COMPOS have went to Oxbridge. Okay, so that's our result. It's not just because of COMPOS, but we do see an increased result for people who did do COMPOS. How do you do the follow along program? So you just tell us, I want to join the follow along. You automatically get an invitation to the follow along program if you don't get into the main one. Okay. We'll send out an invitation to everyone, and yes, or you can email us and say, please can I join the follow along program? And just indicate your COMPOS ID and that you're a year 11. Right. Okay, so let's start. Today's topic is combinatorics. Combinatorics is a area of maths responsible for counting things. Okay, so if you want to count things and you count things properly, that is combinatorics. So the problem one, yes, the main three operations that you use in combinatorics. The first is the number of permutations. Permutations of n objects. That is n factorial. So if you take n objects, there are n factorial ways you can arrange them in order. Okay? Does that make sense? I hope it does. Your permutations. N ways of arranging n objects in order. And then choosing, so n choose k, ways of choosing k objects out of n. K objects out of n. Order does not matter. Not matter. And npk, ways of choosing k objects out of n, where order matters. Okay. So let's do examples. Let's do examples of each, just to make it clear. Examples. There are 6 factorial ways. 6 people can stand in line. Stand in line. 6 factorial ways. 6 factorial is 720. How do I change the settings? Join order. Yeah, try leaving and rejoining. Attendance. We tutorials in small groups. You need 75% attendance. Okay. Webinars are not mandatory. Like the webinars are recorded. and they're not mandatory. But hopefully they're interesting. Choosing. There are 6 factorial, which is 720. There are 6 choose 3 ways of choosing 3 objects out of 6. I'll answer the questions at the end. Sorry. 6 choose 3 ways of choosing 3 objects out of 6. And 6 choose 3. Are you familiar with the formulas, I hope? Is 6 factorial divided by 3 factorial, 6 minus 3 factorial. And 6 factorial. Sorry, would you like, does everyone know what this is? Would you like me to explain what this is? How to use this formula? Okay. Right. So the formula for n choose k, let's start with that. N choose k is n factorial divided by k factorial multiplied by n minus k factorial. Suppose you have 4 apples. You want to choose 2 out of 4, of course. There are 4 choose 2 ways you could do that. You can do this. So 4 choose 2 is 4 factorial divided by 2 factorial using just the formula 4 minus 2 factorial, which is 4 factorial divided by 2 factorial multiplied by 2 factorial. 4 factorial is 1 times 2 times 3 times 4. And 2 factorial is 1 times 2 and 1 times 2 again. So if you, that's 4. So 1 times 2 times 3, that's 6. 6 ways. Let's confirm that this is indeed true. Let's say you have 4 apples. 1, 2, 3, 4. You could choose 1 and 2. You could choose 1 and 3. You can choose 1 and 4. You could choose 2 and 3. You could choose 2 and 4. Or you can choose 3 and 4. There are 6 ways to choose. 6 ways. How well do you understand this example on a scale of 0 to 10? Okay, lovely. Lovely. So if it matters which apple you eat first, so here it doesn't matter which apple you eat first. It doesn't matter which apple you choose first. But let's say it does matter. So NPK is a very similar construction. NPK is n factorial divided by n minus k factorial. So it's very similar, except there's no k factorial at the bottom. You have 4 apples. You have 4 apples. You want to choose, you want to eat 2. There are 4 P2 permutation, 4 permutation 2 ways you can do this. You can do this. Right. So let's calculate 4P2 first. So 4P2 is 4 factorial divided by 4 minus 2 factorial. which is 1 times 2 times 3 times 4, divided by 1 times 2, because that's 2 factorial. 1 times 2 cancels, and you get 3 times 4, which is 12 ways. So what is the difference? Well, the difference, now you have twice as many ways, because you can eat apple 1, then 2, or you can eat 2, then 1. You can eat 1 and 3, you can eat 3 and 1. You can 1, 4, 4, 1, 2, 3, 3, 2, 2, 4, 4, 2, and 3, 4, 4, 3. So there are 12 ways. 12 ways. So here order matters. Order in which you choose objects matters. And in the previous one, order does not matter. Okay. Could doing this C formula doubled? No, it wouldn't. It would be C times 2 factorial. Yes, that would work. So if you analyze these two, you will see that there's a link. If you multiply the C formula by K factorial, so n choose C, n choose K multiplied by K factorial would give you NPK. So that is an important result. Right. So, and choose 3 object out of 6 where order doesn't matter. And there are 6p3 ways of choosing 3 objects out of 6 where order matters. Okay. Problem 1. How many words existing of 4 letters in the English alphabet? Well, when we say words in math, we mean any combination of letters. So if you have 4 letters, so there are 26 possibilities for the first letter. There's 26 possibilities for the second, 26 and 26. So it's for A, it's 26 to the power 4 words. It's quite straightforward. If it's five letters, of course, it's 26 options. So B is 26 to the power 5 words. What if the letters are not allowed to repeat? So repeats, no repeats. Okay. So let's say I'm making a 4-letter word. There are 26 options for the first letter. Yes, lovely. 26 factorial divided by 22 factorial. Actually, yeah, that is 26 times 25 times 24 times 23. No repeats, so it's 26 times 25 times 24 times 23. Let's see if there's a link, because aren't you just doing exactly what we've discussed previously? Aren't you just choosing 4 letters? So choose 4 letters out of 26. Order matters, because the order of letters matters. If you change the letters, it's a different word. then this is going to be 26p 4. You're choosing 4 out of 26. So it's 26 factorial divided by 26 minus 4 factorial, which is 26 factorial divided by 22 factorial, which is, if you think about it, this is 26, so 1 times 2 times 3 times etc. times 26, whereas here it's 1 times 2 times 3 times etc. times 22. When you cancel out the top and bottom, you're left with 23 times 24 times 25 times 26 over 1, which is, well, 23 times 24 times 25 times 26, whatever that is. I'm not really interested in what that is, but that's it. So similarly, which is the same as 26p p4. Here it's going to be 26p5, as you could have already guessed, which is 26 factorial divided by 21 factorial, which is 22 times 23 times 24 times 25 times 26. Oh, thank you. 358,800. Big number. Okay. So I've used two different approaches. I just saw, so if I create 5 spaces and I just look at the number of possibilities, so I just need to multiply them. Or I said, well, there are 26 letters and I want to choose 4 of them, and the order in which I choose them matters because A, B, C, D and D, B, A, C are different words. Okay. That would be so efficient. Like, and I imagine an average person has a vocabulary of maybe 50,000 words. Like, you could, all words could be 4-letter words. Okay, problem 2. How many ways can you choose 2 duty officers and 1 senior duty officer from a group of 12 people? So this is where you need to get inventive. I mean, you could use formulas, but you could, I don't know, try using common sense. So I'm going to say this. You have 2 duty officers and 1 senior. So duty and senior. Senior. Um, 12p2 times 10p1. No, I don't think so. No. Yes, Vishaka, I think you're right. So what you can do, so you say, okay, the duty officer, let's say the first position, we have 3 positions to fill. The first position, there are 12 people. That means there are 12 possible candidates for the first position. Once that position has been filled, there are 11 candidates for the duty for the second position. And then we're left with 10 people to choose for the senior officer. So you have 12 times 11 times 10. possibilities. However, let's say you've chosen 3 people, A, B, and C. A, B, and C. But B, A, and C is also a choice, but it's exactly the same. It doesn't make a difference. The order in which you choose the duty officers doesn't make a difference. And for each choice, there are 2 possibilities. And that is why you have to divide by 2. Well, 2 factorial. Because there are 2 factorial ways to rearrange the duty officers. So out of all the possibilities, we have to divide by 2 factorial. So 12 times 11 times 10, which is 12 times 11 is 132. 1320 divided by 2 factorial, which is 2. So it's going to be 660. Yes, ways. Let's see if 10 choose 12 choose 2 and 10 choose 1 works. 12 choose 2. Yeah, it works. Yes, let's do it a different way. Alternative. Option 2. Option 2. 12 choose 2 ways of choosing duty officers. And then you're left with 10 choose 1 ways of choosing senior officer. Okay, so 12 choose 2 is 12 factorial divided by 2 factorial times 10 factorial, which is 11 times 12 divided by 2, which is 106, that's 66. And 10 choose 1 is 10 factorial divided by 1 factorial times 9 factorial, which is 10. And then 66 times 10 is 660 ways. Okay. So you see, I'm using different approaches for solving the same problem. I'd like you to appreciate that it's kind of an intuitive topic. Okay. It was a different problem, but let's modify this problem. C, D. On a train with 7 cars, 7 cars on a train with 10 seats. Train with 10 cars. The cars are single. No, students don't share cars. No sharing. So 1 person per car. 1 person per car. It's a little tiny train. So what's the difference? Well, they are on a train, so the train has a front, so the cars are numbered. Cars. There are 7. 1, 2, 3, 4, 5, 6, 7. So question A. There are 7 students and there are 7 cars. Well, there are 7 students, so there's 7 factorial ways. 7 factorial ways of arranging. Alternatively, you can say the first car, there are 7 possibilities, so 7 possible passengers for this first car. There are 6 possible passengers for the second car, 5 possible passengers for the third car, 4, 3, 2, 1. And it's 7 times 6 times 5 times, etc. Is 7 factorial. Arranging 7 students. You could also say, well, it is 7p 7. So you're choosing 7 students out of 7 is 7 factorial divided by 7 minus 7 factorial, which is 7 factorial divided by 0 factorial. Who knows what 0 factorial is? 1, of course. Why is 0 factorial 1? Because if you have two objects, 2 factorial is 2 objects. 1 factorial is the number of ways to arrange n objects. N factorial is the number of ways to arrange n objects. So there are 6 ways of arranging 3 objects. There's 2 ways of arranging 2 objects, so A, B, and BA. There's only 1 way of arranging, so 3 factorial is 6, 2 factorial is 2, 1 factorial is 1, 0 factorial is 1. There is 1 way of arranging 0 objects. It's just his 0 objects. That's the only, yeah. So yeah, so we're arranging 7 students, so 7 factorial over, so that's 7 factorial over 1, which is 7 factorial. Now, if you have 10 cars, once again, you can do this in 2 different ways. You can say that, ooh, can you do that? No, not really. Basically, first you need to choose which cars to occupy. You need to choose which cars you're gonna use. So there are 10, choose 7. But that's exactly what it is. Oh, of course, yeah. You have 10 cars, you're choosing 7 and the order matters. So 10p7, 10p7 ways. You're choosing 7 out of 10 and order matters. 600. Well, it matters in the first one. If you have 7 students taking 7 cars, if the order doesn't matter, there's only one way of putting 7 students in 7 cars. The order in which when we say order matters, we mean it matters which student goes into which car. C. Now it's a carousel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a carousel, and they're arranged in a circle. 2, 3, 4, 5, 6, 7. So what's different here is that 1, 2, 3, 4, 5, 6, 7 and 2, 3, 4, 5, 6, 7, 1 is the same. The same. Because it doesn't matter. Like 1, 2, 3, 4, 5, 6, 7 or 1, 2, 3, 4, 5, 6, 7 from here. It doesn't matter where you start. I was a bit confused with this question, but the here the seats are identical. Yes, thank you, Vishaka. It's 7 factorial over 7 because there are 7 equivalent arrangements for 7 there's 7 possibilities of each arrangement. 7 identical arrangements for each choice. And that means it's 7 factorial divided by 7, which makes it, well, 6 factorial, because 7 factorial is 1, 2, 3, 4, 5, 6, 7. Over 7, that's 6 factorial. So 6 factorial. And D, so, well, it's the same. You have 10 seats. So there are 10 identical ways. Yes. So there's 10 seats. One, two, three, four, five, six, 7, 8, 9, 10. So for example, 1, 2, empty, 3, 4, empty, 5, empty, 6, 7. So these are the numbers of students, and then empty seats and 2 empty, 3, 4 empty, 5 empty, 6, 7, 1 is the same. The same. I hope you understand what I mean. So when you see 1, 2 empty, 3 student number 4 empty, student number 5, student number 6. So empty, student number 6, student number 7. It doesn't matter where you start counting. So it's a carousel, it's a circle. And the circle, it don't matter where you start from. Yes. Thank you. So you need one of each of the 7 arrangements, as it were. Well, yes, you just divide by 7 because n factorial will give you, oh, so in this case, it's going to be, so there are 10 identical arrangements in the same order. And that means that it's going to be, so you're choosing 10p7 divided by 10. Interestingly, that's going to be, that's 9 factorial divided by 3 factorial divided by 10, oh, sorry, 10 factorial divided by 3 factorial divided by 10. That's 9 factorial divided by 3 factorial, which is 9p6. Ooh, that's unexpected. in a way. I didn't expect that result. Okay, problem 4. In how many ways can 10 apples be distributed amongst 3 people, ensuring that each person receives at least 1 apple? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 apples. 3 to the power 7. I don't think so. I don't think so. Okay, so here you have 10 apples. And what you're going to do is you're going to split those apples into 3 groups. So basically what you need to do is you can draw like this and like this. So you need to place 2 dividers between apples. So all these apples go to person 1, these apples go to person 2, and these apples go to person 3. We're assuming that apples are identical here, because if we don't assume apples are identical, we get into a whole other calculations. Apples are identical. Are identical. So how does that work? Well, we can say, look, we can, the easiest case we can do like this. And then the first person gets 1 apple, the second person gets 1 apple, the third person gets 8 apples. Then we can move the divider here. And that makes it 1 apple, 2 apples, 7 apples. Okay. Or we can move the divider like this, and it's 1, 3, 1, 3, 6. It's actually won't take long to go over all of these, all of the possibilities. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 gaps. 9 gaps to place 2 dividers. Order does not matter because order does not matter. Not matter. So there. Oh. So there are 9 gaps. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you need to choose 2. So for the first divider, well, it's 9 gaps. For the second divider, it's 8 gaps. But the order doesn't matter, so you divide by 2. It is, indeed. It is 9, choose 2. So rather than counting that, which is possible, and it's not the end of the world, but 9 gaps to place 2 dividers. So there's 9 choose 2 ways to place the apple dividers. There's divide and rule, divide and apple. Yeah, so yeah, that's 9 choose 2. Let's calculate that for a change. So that's 2 factorial, 7 factorial. So that's 8 times 9 divided by 2, which is 36 ways. 9p2, because the order in which you place, like, divider A and divider B, it doesn't matter which one goes first. If you switch them around, nothing changes. 9, 9 because you have 10 apples in a row. You want to place dividers between the apples. So there's divider A and divider B. So you can move the divider around, and that changes the number of apples. So in this case, person 1 gets 4 apples, person 2 gets 2 apples, and person 3 gets 4 apples. So there are 9 possible positions where you can have each divider. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And you need to place, yeah. Tanya, does that make sense? Could you assume everyone takes one apple and then do a combination with the remaining 7? What kind of combination? I can't see a combination that won't give you 36 with 7. Well, the 8, there will be 8, but still, yeah, it doesn't. Could you assume everyone takes one apple and do a combination with the remaining 7? 9, 2 anyway, you should. 9 position. How come you get 9? There's 7, there should be 8 positions. It's kind of rare, but are you allowed to help? Are you allowed to help us with actual questions and assignment? I can give you hints, yes. At the end of this session, well, reasonable hints. Of course, I won't show you how to do things, but I will try to point you in the correct direction. Are sure everyone has 2 apples? It would be 8. Choose 2. I don't think it would be 8. Choose 2. It would be a bit more complicated. Just. I can't immediately think of how to calculate it if everyone has to have at least 2 apples. If everyone has to have at least 2 apples, give everyone 1 apple and then repeat the question. By the way, I think that it's a completely valid method. Give everyone an apple and then place the dividers. But it can't. Oh, because when you don't assume that everyone gets an apple, you can place the dividers together at the same position. So it's like 8 positions, but 2 dividers can occupy the same position. So it gets really messy. So I wouldn't recommend that. But with 2 apples, it will work. Give everyone 1 apple, and then repeat the problem. Okay. How many ways can you divide 12 people into 2 teams of 6? Well, if you think about it, you only need to choose 6. Because if you choose 6, the other 6 are there. Yeah. So 12 choose 6 ways to choose the first team. Well, and then 1 way to choose second team. Because if you've chosen the first team, you've automatically chosen the second team. So the answer is 12 choose 6. 12 choose 6, which is 12 factorial divided by 6 factorial, 6 factorial. So that's going to be 7 times 8 times 9 times 10 times 11 times 12 divided by 1 times 2 times 3 times 4 times 5 times 6. 2 and 6 make 12. 8 divided by 4 is 2. 9 divided by 3 is 3. 10 divided by 5 is 2. So we're left with 77. 7 times 2 times 3 times 2. So that's 12. 12 times 7 is 84. 84 times 11. 84 times 11 is 924, isn't it? It would be embarrassing if it's wrong. 2 times 3 times 2 times 11. 924. Yes, that is correct. Okay, so that's it. That's the number of ways to choose two team. We would explicitly say the order matters. And we're just splitting them into two teams. We're not saying that they have specific roles in teams, right? So we would say, how many ways can you divide 12 people into teams of 6 with 1 goalkeeper, with 2 defenders and 3 attackers? Yeah, usually say 924. You multiply them. It's a multiplication principle. You use the multiplication principle when you do both at the same time. So yeah. And addition, when they're mutually you use addition only when these are mutually exclusive. But obviously it's not. If you choose the first team, you choose the second one. You first do this first team, then you do the second one. They're not mutually exclusive. Okay. There are 6 identical red balls. 5 identical. You would think so. But the problem is that the 6 identical red balls, if you switch them around, let's say we have an arrangement. So we have red, red, blue, green, etc. If you switch these 2 red balls, it doesn't change. You won't be able to. So the order the order of the colors matter, but the order of red balls, for example, the order of blue balls doesn't matter. So if there are 6 red balls, there are 6 factorial arrangements. Thank you, Vishaka. Yes, that is correct. I hope that's division. Arrangements of 6 balls, 6 red balls. There are 5 factorial arrangements of 5 blue balls, and 4 factorial for green balls. 4 green balls. And of course, there are 15 factorial ways of arranging 15 balls in order. So 15 over 6 factorial times 5 factorial times 4 factorial. And then, okay. You get something. Sorry, I'm a bit lazy to calculate it. I'll just plug it into my calculator. 15 factorial. By the way, if you have a semi-decent calculator, it should do factorial. 6 factorial times 5 factorial times 4 factorial. Oh, that's a beautiful number. 630, 630, 630, 1,630. Don't get why dividing by 6 factorial twice. Well, Where? Oh, here. Because the formula for 12 choose 6 is 12 factorial divided by 6 factorial divided by 12 minus 6 factorial, which is also 6. Why do you divide by 15 factorial? But I don't. Where's 15 factorial? You do 15 factorial divided by 6 factorial, 5 factorial, 4 factorial. So 15 factorial is the total number of 15 balls if the balls were all different. But because 6 of the balls are the same, we divide by 6 factorial. Because the 5 balls are the same, we divide by 5 factorial. And because the 4 balls are the same, we divide by 4 factorial. 15 balls, because there are 15 factorial ways of arranging 15 balls in order. Just like, yeah. All right. So hope that makes sense. All right. 7. 2 fair 6-sided dice, 1 red and 1 blue, are rolled simultaneously. Calculate the probability that the sum of the numbers is rolled is a prime number. Okay. Well, 2 fair 6-sided dice. Calculate the probability that the sum of the numbers is rolled is a prime number. Okay, so this is a probability question. This is a very basic probability question, and so there's 36 possibilities. 36 possibilities altogether. You can even draw a table. That's by the way, a very useful one. 1, 2, 3, 4, 5, 6. This is a score on die 1, and the score on die 2 is 1, 2, 3, 4, 5, 6. And the sum is a prime number. Okay, so 1 and 1 is 2, 1 and 2 is 3, 1 and 3 is 4, 1 and 4 is 5, 1 and 5 is 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. So we can see the minimum score is 2. The maximum score is 12. The most probable score is 7. Then an interesting thing, if you play Monopoly board, if you take the classic Monopoly board and if you play against the computer will be very, very reluctant to sell these orange ones. And they say that the orange ones are the most valuable in Monopoly because you very often come into jail and then you roll 2 die and it's 1, 2, 3, 4, 5, 6, 7. The most probable score is 7. So you're most likely to land in orange if you come out of jail in Monopoly. So yeah, if you ever play anyone and you manage to buy the orange ones before somebody flips the table. Yeah, so the most probable score on 2 die is 7, and that as you can see from this table. So there is 36 possibilities. We just need to highlight the prime values. So prime, 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 and prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 15 out of 36. That's the probability of prime is 15 out of 36. That's it. Okay. Why does order matter? Wouldn't a person receiving 2 apples while be receiving? Sorry, is this not to do with the order matter as wouldn't person receiving 2 apples while B receives 1? Yeah, the order. So for this question with the apples, the order in which you place the 2 barriers, the 2 barriers just separate person 1 and person 2 and person 3. So if you were to switch the barriers around, that won't change. The first person still has 4 apples. Person 2 still has 5 apples, and person 3 still has 1 apple. Yeah, does that make sense? So if you change the barriers around, so the order of the barriers doesn't matter. The order in which we give piles of apples to people certainly does matter, yeah. But that's a different story. Okay, now it's a bit of a cheeky problem because it is in the assignment, except in the assignment is 23. There are 12 people in the room chosen at random. What's the probability that at least 2 of them share a birthday? That's that's a classic problem. It's called the birthday paradox. Although the number is wrong, but the correct number is 23, and it's given in the assignment. And hopefully you'll get them. But you can look up birthday paradox. Okay, so the problem here, if you start analyzing this, is that you could have 2 people sharing birthdays, or you can have 3 people sharing birthdays, or you could have two pairs of people sharing birthdays, or you could have 3 pairs of people sharing birthdays. So it gets really messy really fast. So calculating all the possibilities, it could be 2 people, or 2 plus 2, or 3 plus 2. Yeah, we can have 3 people sharing 1 birthday and another 2 sharing birthday, date and month, yes. Yes, Zidane is correct. It's roughly 50% if it's 23 people. But how do you actually do the calculation? That's the problem. And what we have to realize is here, what we need to calculate is what is the chance that they don't, that nobody shares a birthday. So let's say A is someone shares a birthday. And then A dash, no one shares a birthday. At least 2 people. 2 people share a birthday. Sorry, I forgot how to English share a birthday. No one shares a birthday. And the interesting thing is the probability of not A is equal to 1 minus probability of A, and vice versa. The probability of A is 1 minus the probability of not A. So what we need to do is we need to calculate the chance that nobody shares a birthday. So for the first, in how many ways? There are 365 days. So there are 365 to the power 12 ways 12 people can be born. Then we have, if they are not allowed to share birthdays, if they are not allowed to share birthdays, the first person has 365 possibilities. The second person has 364 possibilities. The third person has 363 possibilities, etc. So then up to minus 12, 354. Yeah, 354 possibilities. So the probability that no one shares a birthday, so that's probability of A, that's 365 times 364 times 363 times etc. 354 divided by 365 to the power 12. And that will give you something. Well, that's actually 365p 12 divided by 365 to the power 12. So 365p, your calculator should have a p button, divided by 365 to the power 12. So you could actually do it on your calculator, like that. If you don't have a calculator, do get one. These, you can get these secondhand for £10. 0.83, 0.83, yes, 0.833. That's the probability that no one shares a birthday. Therefore, the probability that someone shares a birthday, is 1 minus probability of A, so that's 1 minus 0.833, which is 0.167. So it's roughly 16.7% that somebody shares a birthday. Okay. Hopefully that's, oh, thank you. Rizkosh. Lovely. So that's that. That's the end of maths for today. I'm happy to answer your questions. I'll spend another few minutes. 665, because the first person can be born in 365 ways. The second person can be born in 365 ways. The third person can be done in 365 ways, etc. Problem 11. Well, we can't do problem 11, but we can discuss problem 11. Maths. Let's have a look. Yeah, in questions like this, leap years don't play a part. We just ignore those unlucky few who were born in the 29th of 29th of February. In the city where absent minded scientists live, phone numbers consist of 7 digits. The scientist usually remembers a phone number if it's a palindrome. And from left to right or right to left. For example, it's easy for the scientist to remember because it's a palindrome. However, a number is not a palindrome. Probably the phone number of a new random acquaintance, it will be easy for the scientist to remember. Well, here, there's not much I can say. Not much I can say without giving away the answer, but if you know the first digit, you immediately know the last digit. If you know this second digit, you immediately know the second to last digit. So you just need to calculate with a given number how many possibility. What is the yeah? How many ways for it to be a palindrome, and how many ways for it is not to be a palindrome? If that makes any sense. Or you can start. What if the first number is 1? How many palindromes are there? Okay. Yeah. So I hope that helps. I hope that helps. Just think of it. If you know the first number, you immediately know the last one. So that's how you should be thinking. Problem 10 on mathematics. Well, you just expand them separately. You expand the first one like this. Then you expand the second one exactly in the same way. And then you have 2 brackets and you multiply them out, just like you did in year 9 or year 10. You expand the first one, then multiply them out. Well, not really, because how would you use the binomial? If you multiply them first, you don't have a binomial, you have a trinomial. And potentially you could use the binomial formula twice, but I wouldn't touch that with a 7-foot pole. Yeah. But it's 1 minus. It is. Sorry, it is a binomial, anyways. But then you still have 1 minus 2x squared. You still need to multiply it out. You could do 1 minus 4x squared to the power 4 times 1 minus 2x, but why would you? You just open them up. You don't need to open them up completely. You just need to see which one gives a coefficient of 7. Oh, that's Harlev. That's no, that doesn't work. Sorry, I can tell you that. problem 7. Problem 7. You can use Pascal's triangle, yeah, by all means. The coach has to pick a team of a goalkeeper, 4 defenders, 4 midfielders. That problem is exactly this problem. Is exactly this. You just, instead of red balls, you have football players. Problem 9 on maths. Well, just, yeah, add. Do you understand what they are asking? Calculate the sum of owners in each of the first 7 rows of Pascal's triangle. So just add the numbers in the rows and try to come up with a formula. Right. After the entrance assignment, are the future homeworks weekly given, and will there be any exams at any point of the course? We don't have any exams. The homework is your exam. If you complete 75% of your homeworks, you will receive a letter saying that you have completed COMPOS'. Homework is given every month, so there will be 6 homeworks over the until February. Okay, so you finish in February. So I'll come back to this. So this runs from October to February. So there are 6 homeworks. That's 6 maths and 6 physics. We always, so we give them every month. So you have 4 weeks to do it. And for each homework, you have 3 tutorials. 3 tutorials for each homework. Is the passing score an average of both papers, or you have to do a passing score in both papers? So typical passing score was 50%. However, we did accept 40 and 60. We did accept 40 and 60, but we didn't accept anyone like 30-70. We don't accept 30-70. So the rule last year was you needed to score 50 on average plus at least 40% on physics. I don't think anyone got 60 on physics and 30, like 60 on physics and 40 on maths. It was usually the other way around. Could you please show a hint for problem 8 and explain what the end part means after part B? Problem 8. An ice cream shop sells 3 flavors of ice cream. In generalize, you mean this bit or after part B? Well, if you have instead of 3 flavors, 3 flavors and 3 scoops. But here you have M flavors and N scoops. So Basically, you need a formula in terms of m and n. That's what it means. You just need to give an answer, give you your answer in terms of m and n. All right. How do you do 5 question B? The n number has to be odd. 5 question 5b. How many odd 6-digit numbers can be made using? It cannot be repeated. Well, you can do it like, what if the last digit is that? Well, in this case, it's actually quite simple because the last digit is known. Do all of us who submit this assignment get in? No, you need about 50% to get in. But you can, you don't even need to submit anything if you want to do the COMPOS follow along. So if you think that 5 hours of homework every week is too much, and 75% attendance is too much, you can just do follow along. You don't have to submit anything. So you just do as much as you can if you wish. Roughly, yeah, the passing score was 50% last year. We don't know the passing score. We have the same number of applicants. I can tell you that. We have the same number of applicants, and it's likely to be very similar. But sorry, can't make any guarantees. Could you please show a hint for problem 8 and explain? Okay, I've done that. I did my work on a Word document and a Google Note. Is that okay? Yeah, certainly, but you need to submit it as pictures, right? As images. So you can do screenshots or you can do photographs. It's up to you. If you pass with 50%, you're guaranteed in. No, unfortunately, we don't know. What would happen if you never attended the tutorials but scored highly on the assignments? We'll ask a lot of questions. Look, if you're in a group, that means we pay the tutors, right? And if you don't show up, we'd rather have someone else that did show up. So you're welcome to do the assignments and do the follow along. So if you don't want to go to the tutorials, you need to tell us, and we'll just place you in the follow along. If you submit all the work, you still get the same recognition. You're treated exactly the same as somebody who completed the main COMPOS program. But if you're not planning to attend tutorials, please let us know it in advance, because then we can give your place to somebody else. Yes, the general is a bit. Can you also 4 in physics? I don't have time for physics today. Sorry. Confusing probability question where 12 people share, but why do you divide by 365? Wait, because that's the total number. So you get the number of the outcomes that you want divided by the total number of outcomes overall. So there's 365 P12 ways in them not sharing birthdays, and 365 to the power 12 overall. So it's like with on a dice, you divide by the number of favorable outcomes divided by 36. How can we enroll in follow along? Just send us an email and we'll make sure. But as I said, everyone who doesn't get into the main COMPOS is invited to the follow along. Follow along is the same as COMPOS. You don't get tutors, and your work doesn't get marked until the end of the year. Yes, that is correct. So you won't receive feedback on your work, unfortunately. How many applicants apply? So this year we have 2,800 applicants, same as last year. But don't let that discourage you. Last year we accepted half the people who actually completed the first assignment. So if you complete the first assignment, there's potentially a 50% chance to get in. Do you get specific tutors during the course? Well, the tutors are assigned based on availability. If you tell us you're available only on Tuesday evening, we will give you a tutor that is available on Tuesday evening. What is the difference between tutorials and webinars? Webinars is what you see now. Tutorials are in small groups of 8 students. Well, 8 to 10 students. And you have the same tutor every week, and the tutors mark your work. When are tutorials? Tutorials start in on the 4th of November. How long is each tutorial and how often? They're 90 minutes and they're every week, but there's 3 tutorials per month. So every 4th week is a week off. So there's 3 tutorials per month, yes, and they are every week. If you get a place this year, do you have to reapply for year 12? If you complete the year 11 program, you get an automatic place for year 12. After we submit our assignments on the 10th of October, how long does it usually take to get marked? We'll try to do it in a week, but I can't promise. You don't reapply between year 10 and 11, but you have to for year 12. No, that's not correct. If you finish year 11, you automatically go into year 12. If you finish year 12, you automatically go to year 13. You need to let us know, but sorry, you filled in the application form, but we see that it is you and you automatically get a place. So you apply, but you don't need to compete for a place, if that makes sense. Can you submit typed answers for the first time? Do they have to be handwritten? No, they can be typed. If you want, if you want to really get into typing, you can do LaTeX. That's how we create the assignments in LaTeX. LaTeX. So if you have the energy, you can LaTeX them, but not necessarily. Not necessary. I have to finish here. I hope I have answered your questions. Sorry if I missed some of the questions. There's just so many. I won't be here next week, so we'll skip next week. I will make an announcement when the next webinar is, but they are at the same time every week, but not sorry, they're same time on Tuesdays, but not every week. Yes. I'll see you all. Bye.